All right, so the point of this unknown molar mass is just to sort of harp into your head that we're trying to take grams and divide it by moles. So if you take grams and divide it by moles, that'll always give you something from the periodic table. And then you can either identify what you have that way, or even in a more in-depth way, figure out what compound it is. Um, so for this first one, moles is given and grams is given. So this is sort of the easy one, where you just take the grams and divide it by the moles. And that gives you 166.8. And that's grams in every mole. And so then if you were going to go look at the periodic table and see what's 168 or 167-ish, right? So that's erbium. So that's about what the mass of this thing is. It's about the mass of an erbium. Or there could be a mixture of like carbon, nitrogen, hydrogen that when they add up is 166.8. So that would be that as well. So this next one has atoms, and atoms is not moles. So we need to convert this to moles. And as you can recall, uh, hopefully from my video, that Lady Gaga starts screaming when she sees the word atoms. And since there's 6.02 times 10 to the 23rd atoms in 1 mole, that'll give us our moles. So if you have atoms, you got to figure out your moles, and that's 8.67 moles. And then from that, we're going to divide our mass that's given, which for these problems, it'll always be given. And then you divide it by the moles, which is the 8.67. And that'll give you 119. All right, so 119 grams per mole, if you go to the periodic table, is going to be ballpark, I think, 10. Yeah, so it's ballpark 10. Since it said atoms, it's not a compound. If it said molecules or formula units, then we might be looking at a compound. But since that's atoms, uh, that would be 10. All right, so that is the unknown molar mass. For the next thing, the best I could come up with was if you think of a pizza as always 8 slices, right? If you get it from Domino's or whatever, sometimes if you get it in Ohio, they do them in square pieces and they're not uh, triangles like this. But anyway, if you have two pizzas, then 2 times 8 is 16 slices, right? Because slices is a subset of the pizza. There's less pizza than there is slices. And then in 100 pizzas, you'd have, right, 200 slices. Oops, that's not true. 8 times, you'd have 800 slices. There we go. And then, right, in 6.02 times 10 to the 23rd pizzas, you'd have 6.02 times 8 times 10 to the 23rd, right? Because a pizza is a larger thing than the slices. Another way to think of it with molecules is right, every bike has 2 pedals. So if you have 10 bikes, you have 20 pedals on that bike. And if you have a mole of bikes, then you'd have 2 moles of pedals. And the point of that is if we're looking at a molecule of sugar, C6H12O6, then that molecule contains, um, right, we have 6 carbon atoms. So if we have 6 carbon atoms, then for every molecule of this, we have 6 atoms. Whoops, that's not fun. We have 6 atoms of carbon for every molecule. And for every hydrogen, right, for every molecule of sugar, we have 12 hydrogens. So there's 12 atoms of hydrogen for every 1 molecule of sugar. And then there's also 6 atoms of oxygen for every 1 molecule of sugar. So just like with the petals, right? The fact that every bike has 2 petals and every molecule has 6 carbons, that's why this is true. And then if we had a mole, so we learned in the lab that a cup is about 180 grams. So this is about 180 grams. And since it's about 180 grams, that's about a mole, right? If you add all this stuff up, it's 180 grams. So for a mole of this, you'd have 6 moles of carbon because carbon is a subset of the sugar, right? So you'd have 6 times as much carbon as you had sugar. And you'd have 12 times as much, I guess we'll keep with that, 12 moles of hydrogen, because you have 12 times as much hydrogen as there is sugar. And then you'd have 6 moles of oxygen for every mole of sugar. So it's because this structure contains 6 oxygens that every time, if you had 6.02 times 10 to the 23rd molecules of this, you'd have 6 times as much atoms of oxygen. All right, so doing these problems like that, this is to teach you that basically the mole is a great jumping off point. So if we have 1.25 times 10 to the 24th molecules of sugar, how many moles is that? Well, we need to, because we see the word molecules, use 6.02 times 10 to the 23rd. So we're going to go 6.02 times 10 to the 23rd molecules in 1 mole. In 1 mole. And that is going to give us a great jumping off point for this stuff. So that is 2.08 moles. And now you will see that when we want grams of that, right, that's what we use. We use the moles. So to find grams of that, what we need to do is make our little table with atoms and mass and figure out that there are 6 carbon atoms, each one with a mass of 12, and there are 12 hydrogen atoms, each with a mass of 1, and there are 6, oops, that should be an oxygen, 6 oxygen atoms, each with a mass of 16. So that's 72, and that's 12, and that's 96, I believe. And when you add all that up, you should get 180. Yes. So if we're converting moles to grams, which is what we have here, so we have our 2.08 moles, and for every 1 mole, there's 180 grams, right? That's what we got here. There's 180 grams for every 1 mole of that, and that gives us 373 grams of sugar. Now, how much of that is carbon? So how much of that 373 grams is carbon? There's 2 ways to do this. We can start with the moles again. So we can start with that 2.08 moles of sugar, and we know that for every 1 mole of sugar, there are 6 moles of carbon, and that for every 1 mole of carbon, there are 12 grams. So grams to mole we got from the periodic table. This came from the periodic table. Moles to sugar we got from the formula. All right. And so when we multiply all that out, we get 149.76. So, 150-ish. 150 grams of that 373 grams is carbon. Now, since we've already covered the percent carbon, you could also have done it that way. You could have also, because it's math and there's multiple ways, you could have taken this 72 and divided it by the 180 and found out that your percent carbon is equal to 40%, right? And then multiplied the 373 by 40%, and you would have gotten the same, uh, 149, 150 grams of it is carbon. So that's another way to get to the same answer. I like starting with moles every time because it kind of reinforces that moles, why that's important. But just in case you're a clever clogs, as Peppa Pig says, you might find another way to do it and be like, well, is this right? Yeah, it is. So atoms of oxygen, we're going to stick with that moles, 2.08 moles. So we're going to stick with our 2.08 moles of sugar. And then we're going to convert that to, for every 1 mole of sugar, there is 6 moles of 6 atoms, well, 6 moles basically, of oxygen. And then 1 mole of oxygen has 6.02 times 10 to the 23rd atoms. So that'll give you your atoms of oxygen, which is 7.5 times 10 to the 24th. To the 24th. All right, so then atoms of hydrogen, there's twice as many atoms of hydrogen as oxygen. So you can literally just multiply that by 2 and figure this out as 1.5 times 10 to the 25th atoms of hydrogen. That's one way to do it. Or you can do it the way we just did it above, where you start with your moles of sugar and then work your way that for every 1 mole of sugar, there are 12 moles of hydrogen. And then for every 1 mole of hydrogen, there's 6.02 times 10 to the 23rd atoms. Oops. All right. And then when you do that math, you get the same thing. You get 1.5, I think you get 1.50 times 10 to the 25th. So the same answer. All right, so how many atoms of carbon are there in 1.23 moles? So this is a different number of moles, so sort of a different problem. So we have moles and we're trying to get to atoms. So atoms mean 6.02 is going to be involved. So we start with the number that's given, the 1.23 moles of sugar. And then for every 1 mole of sugar, there is 6 moles of hydrogen, or carbon rather. And then 1 mole of carbon has 6.02 times 10 to the 23rd atoms. And that gives you, I didn't do this one. Hold please while I do that on my calculator real quick. So 1.23 times 6 times 6.02. I like to use the E23. And 4.44 times 10 to the 24th. All right. So that's how you do those. Now, if we have this different compound, this ammonium dichromate, to do grams, well, actually to do anything because it's in grams, now that I think about it, that's why. So because it's in grams, we want it in moles. So to do these things, it's helpful to make your little chart and figure out the moles of ammonium chromate. So our nitrogen, if we have atoms and mass, right? So there's that 2 distributes. So there's 2 atoms of nitrogen, each one with a mass of 14. There's 8 atoms of hydrogen, each with a mass of 1. There's 2 atoms of chromium, each with a mass of 52.0. It's like 51.99, so we're going to call it 52. And then there's 7 atoms of oxygen, each with a mass of 16. So this is 28, and this is 8, and this is 104, and this is 112. And when you add all that up, you get 252 grams per mole. So if we're trying to figure out how many moles this is, we're given 50 grams, and we know there's 252 grams in 1 mole. and that's going to give us 0.198 moles. And that's a great starting point for any of these questions. So if we're looking for atoms of oxygen, we know there's 0.198 moles of this stuff, right? And I'm just going to call it stuff because that means as much to you as ammonium dichromate, right? So there's 1.198 moles of this stuff, and for every 1 mole of stuff, we have, if I can only spell it, we have 7 atoms of oxygen. Oh, 7 moles of oxygen. I should make that red anyway, so there we go. So there's 7 moles of oxygen, right? There's 7 moles of oxygen for every mole of this stuff. And we're looking for atoms, so we need to go one more time, and then for every 1 mole of oxygen, there's 6.02 times 10 to the 23rd atoms. And that gives us, for oxygen, 8.36 times 10 to the 23rd atoms of oxygen. All right, so if we're looking for grams of hydrogen, it's good to start again with that moles, 0.198. And then for every 1 mole of stuff, there are 8 moles of hydrogen. And then for every 1 mole of hydrogen, there's 1 gram. So this came from the periodic table. So you multiply those and you get 1.58 grams. So of that 50 grams, only 1.58 grams is hydrogen. And another way to do that would be to figure out the percent hydrogen. So 8 divided by 252, and then multiply 50 grams by that percentage. And you should get the same answer. All right. So that's all I'm going to do with that. I hope you all are doing well.